Machine translation has seen significant advancements recently. However, it is not as effective for low-resource languages as it is for languages that have more data available for training. Additionally, models trained on general data may struggle to translate terminology specific to a particular domain, such as the medical domain. Research has shown that synthetically generated data can be just as effective for training models as real data. Because of this, methods for generating high-quality synthetic training data need to be explored to bridge the resource gap for languages like IsiXhosa. In this project, we explored two of these methods for generating data, as well as comparing how fine-tuning a pre-trained model compares to training a model from scratch using the same large general domain corpus of data. One of the methods for generating synthetic data that we explored is domain adaptation by lexicon induction, or DALI. DALI generates synthetic data by taking a monolingual in-domain corpus and word-for-word back-translating it using a bilingual lexicon. For example, for this sentence, word-for-word back translation works by identifying the word hello, finding its translation in the lexicon, and putting the translation in the synthetic sentence. The same thing is done for the rest of the sentence. The result of this process is a pseudo-parallel corpus of data that can be used for training machine translation models.
While DALI offers one approach to synthetic data generation, I explored another method: forward translation for training English to IsiXhosa models, and back translation for IsiXhosa to English models. So the process for forward and back translation is as follows. We start with real English medical text, shown in step A in the diagram. Now we don't have the IsiXhosa equivalent of this text, and so we need to synthetically generate the translation. To do this, we feed real English medical text into an existing translation model, shown in B in the diagram, in order to generate synthetic IsiXhosa translations, shown in step C in the diagram. This forms the training data that we use to fine-tune the NLLB 200 model on.
In our project, I focused on building the two baseline models. The first was the transformer trained completely from scratch, which learns directly from the WMT22 parallel corpus. The second was the NLB 200 model, a multilingual system pre-trained on over 200 languages, which I fine-tuned for English and IsiXhosa. These baselines gave us two contrasting starting points, one data-specific, the other transfer-based. These models are also important because they set the foundation for evaluating all other approaches. Training from scratch gave us more specialization, while the NLB 200 showed the benefits of prior multilingual knowledge. Together, they helped us to measure how much domain adaptation techniques improve translation quality for IsiXhosa medical text.
Back translation shows significant translation improvements over the baseline models, whilst DALI worsened translation performance. Back translation hence ends up being a more viable approach for synthetic data generation than DALI. And then lastly, we see that creating a model from scratch produces better quality translations than fine-tuning an existing multilingual model such as NLLB.